you're good.
All right. Are you able to hear me? Yeah.
Yeah.
All right, everybody. Today I'm going to do a quick presentation on SDR basics. This is still something I'm learning a lot about and got to play around a little bit with last semester in our HAB program. So first, what is an SDR? SDR stands for software-defined radio. And instead of a complete hardware design like most radios, most of the radio is handled by software. It uses the PC's processor to handle most of the signal processing. And this design allows it to receive and transmit on a wide range of frequencies and makes it relatively cheap. It's also just a small little dongle that you can see in the images below that just plugs into your laptop, and it uses the sound card. And the frequency ranges vary with each SDR. A lot of the RTL SDRs in the bottom of the slide, they range from about 52 to 2200 megahertz. Okay, so what can an SDR do? Well, a lot. Because most of the radio is defined by software, a lot of radio applications that were limited by hardware are now a lot more plug and play. They're also a lot less expensive. And having an SDR, they're really cheap. They normally cost about $15. And so they're great for learning more about radio and signal processing. A couple of the projects I've used SDR for, and I've only received so far with SDR, there are more expensive SDRs that you can use to transmit as well. And if you are going to transmit, you do need a ham radio license. And I can talk more about that process later. But yeah, projects I've worked on, I've pulled images from NOAA satellites. I've monitored APRS traffic, that's automatic packet reporting system. And then just testing different antennas we've built. Other projects that I'd love to work on that I haven't gotten around to are low-cost ground stations, APRS repeaters, radio telescopes, and some people have hacked SDRs that can transmit to open garages, which is pretty interesting. Okay, so back to some of my projects. The NOAA satellites, we built a double cross antenna that you can see Aaron holding on the left. And then we received transmissions from NOAA weather satellites during different passes. So the image in the middle, I think that's somewhere over California and Arizona. And you can see a little bit of cloud cover, and the image gets blurry where there was a lot of noise and we weren't getting a solid transmission. And then the image on the right is a thermal image taken over the Midwest, and you can see the Gulf of Mexico and the different sea temperatures, I guess. The next project that I worked on was APRS traffic, and you can see the Yagi directional antenna we built on the bottom left. And then we received data packets from APRS and decoded it with software. And I'll get into a little bit of how you can set up decoding. And then the image on the right is the packets that we decoded. And you can see call signs and dates and stuff like that. A lot of weather stations and things like that use APRS to broadcast their data. And then we used this method with the snowshoe HAB, and we had some success. We were only able to decode a couple packets, but that was a fun experiment. And so now I'm going to get into a little bit of working through the SDR Sharp software. That's a software that we use to work with our SDRs. So up here is the play button.
Yeah, you may want to turn that down before you start it.
It's down a little bit. So once I hit the play button, you'll start seeing the radio transmissions up here in the viewer, the frequency viewer. I can't remember what is it called? Spectrum.
Spectrum viewer.
Spectrum viewer. And then here is the waterfall where you can kind of see the history, I guess, of the Spectrum viewer. So I'll hit play right here. You're not really going to be able to hear anything because I have it turned down because there's a lot of noise right now. But here you can see most of all this is noise. And I have a handheld radio with me, and I'm going to transmit on 144.8 megahertz. And you'll see this spike up here, and then you'll see the history of my waveform down here in the waterfall. So test 1 2, test 1 2. So here you can see my transmission, and if I zoom in, we should be able to get a little bit more accuracy. So yeah, here you can zoom with it. Check 1 2, check 1 2. So again, here you can see where I was actually talking into it. Here was just the transmission without talking, and then talking again. So that's useful to see where you were where a transmission came through in the past, and help you zero in on it, I guess. So I'm going to zoom back out, and I'll show you guys FM radio real quick. So here you can see different radio stations broadcasting. I'll just lock on this one. And then here you can adjust the volume. $29.99 a month. Call 877. Hopefully that didn't kill your guys' ears. Okay, some other things I'm going to go through in the SDR software. Up here in settings, you can change your sample rate, your bit rate. So different projects, you'll need to use different sample rates. I know with the NOAA satellites, we were using 0.9. And that's just something you have to research with each project that you work on. Right now, I have it set to 2.8, and that works well with the handheld and FM radio. Some other stuff down here, you can change your audio settings, and this is where you can really mess a lot with decoding and different softwares, because if you download a virtual audio cable, you can use that. Here is you can set your output to the virtual audio cable and pipe your audio into different softwares that you can use to decode. So in our case with the APRS traffic, we use Direwolf, and we ran our output through the virtual audio cable input. And then in the Direwolf software, we set our virtual audio cable output to the input, and that allowed us to decode. That could be another video altogether. Right now, I just have it set to our speakers so we can hear it coming out of the software. A couple other things. Here you can do recording, and you can just record audio, or you can record the baseband. And then there's different sample formats. Again, that's something that I've had to play with and mess with on each of the projects I've worked on. Trying to think of what else. Here, also up here, along with the zooming, you can set the contrast. Here, I'll go ahead and play something so you can see it better. You can zoom in, again, like I said before. You can set the contrast for the waterfall. And then you can adjust your bandwidth either here on the side, or you can actually click and drag, and just this will help cancel out noise you don't want to hear and focus in on the frequency you do want to hear. Is there anything else, Chris?
Did you go through the sidebar filters on the left?
Filters?
Just plug into them.
I'm not sure what you're saying.
This stuff.
Yeah. Like I said, there's an audio where you can adjust the inputs and outputs and sample rate, the recording. I haven't messed with much of the other stuff yet, but it looks like there's different filters you can play with to try to cancel out some of that noise. Up here, this is narrow FM and wide FM, and different applications will use different things. Let's see. And then here, you can turn on and off squelch, and so you won't hear any of the noise until your transmission hits a certain decibel range, and then the squelch will turn off and you'll hear the transmission, and then it'll cut off when the transmission ends, and so you won't hear any more noise. I think that's about all I've got. You have any other ideas, Chris?
No, that was good.
All right, everybody. Thanks for watching. Sorry, this is the second recording. Hopefully it worked this time. I'll see you guys later.